Well, running the stepper motors in celebration of us starting there would have worked a lot better if I'd remembered to turn the power supply on. So that's, about par for the course. Hi, good to see you all again here on the Sunday night as we try and make the 3D printed, I keep calling it a DMX controlled winch. I mean, it is in no way so far DMX controlled, except that we, have made some DMX control boards before, and in theory we could control it with DMX. Right now it's just a 3D printed winch. But in theory, someday it will be controlled by DMX and it will go into the miniature stage of 3D printed lights. And won't that just be a joy? Yeah, Thomas, they get, I wouldn't say super hot, but I would say fairly hot. And I don't know why that is, but always an exciting time. But yes, it's lovely to be back with you, good nerds. Thomas, by the way, good to see you, Chris, as well. After a couple of weeks away. Had a lovely time last weekend. Had a fully vaccinated friend passing through town on her way out to see her folks for the first time in 18 months, which is lovely. So we got to see her and a little fully vaxxed social encounter, which blew all of our minds and was super lovely. Yeah, Chris, no lav mic today. So a little bit of behind how sausage is getting made here. The lav mic I use is the Deity lav mic, and in theory, it doesn't use batteries when it's not being used. It just uses its little internal watch batteries to toggle which of the pins is ground and which is left and right mic signal or something like that on the little TRS plug that it has. But I find that not to be the same. Not to be true. It just drains its batteries in about 4 weeks consistently. And I forgot to check before tonight, so we're back on the old clunker. Broke both, good to see you. A pleasure. Thomas says, if the steppers are getting hot, the current setting on the driver is probably a bit too high. Yeah, that seems plausible. We did a pretty casual job of setting that back, I think, on stream a few weeks back. But that's, excuse me, that's an easy enough thing for us to turn down. Speaking of turning down, I feel like the last time we were together, Dave, who I don't know if Dave's with us tonight or will be with us later, mentioned that the music was a little bit overwhelming. So especially with the different microphone setup, let me know if it is distracting, too loud, too quiet, all that good stuff. Why don't we start by turning this current limit down here? I think that's the down direction. I guess we'll find out. If these keep getting hotter, then we'll know I was wrong. So where did we leave off? I actually didn't. I've got so part of the problem is now that this 3D printed winch setup is getting so big that it's inconveniently big for my desk and camera setup that I've made up here. So we've got the main parts of the winch we've been working on here with the stepper motor, the additional bearing, the drive barrel. Here we can zoom in because this stuff's all nicely compacted together, right? Drive barrel, couple of friction washers, the ratchet wheel. You notice I don't actually have the ratchets hooked up to anything because I still need to rework how this ratchet mechanism works because that's, as we discovered, pretty fiddly, and I don't like that. Our front bearing, we have one of our barrels here, but then because this is going to ultimately be a full batten length, I have this hooked up to, I guess it's 3 200-millimeter sections of Cookie's truss. So 60 centimeters of truss is more than I can conveniently fit on camera at this point. I mean, it fits well on my workbench when I don't have the streaming setup going, because I can move the mouse and I can move the laptop that the computer work happens on out of the way. But for the purposes of this, I should have considered better what the actual setup would be. But that's okay. The business end of things, right, of course, is the mechanism of the winch itself where we'll spend the most time. But just note there's another 24 inches of winch going off that way that we're also having to contend with this evening. So I've just basically recreated on the workbench here. I kind of swivel around this microphone as I try to turn the power supply on. But we've recreated the setup that we had a couple weeks ago with our little tester jig. Zoom out there, right? That was just an Arduino Mega because that's what was convenient. And a couple of buttons that are hidden behind my little face camera there to do anti-clockwise and clockwise motion. The main improvements that I have made since the last time we were together, you see, this is that same janky spool that we were working with the other time, but I've actually finally added the grub screw to hold it in place on the shaft. I ground out a D-shaped section on this shaft and put the grub screw in, and that made a huge difference to, of course, these barrels not wanting to slip. what made a huge difference for that was actually getting a tungsten carbide bit for my, well, it's a knockoff. It's a Harbor Freight Dremel, but it's one of 2 Harbor Freight Dremels. So I've got this one, which is a Drill Master brand, which has almost no power. It's really awful, but it's nice and palm size, so it's decent for like doing little, engraving my name into things. And then this one is beefier, if a little bit plasticky feeling, but it's got a decent amount of power, and I put a tungsten carbide bit in it, and I ground this section and a section for the other barrel, which of course is not even in range of the camera, but I have a second barrel out here to play with that I haven't put I've ground a flat section underneath the, of course the stepper is going to fight me there. I just use the controls to step that over. So there's our hole where our grub screw is going to go in, but I haven't put the threaded insert or the grub screw in that yet. I was actually just playing with that earlier today. Let's see if I can get this button back in my control setup here. There we go. So one of the things we left with, that's getting pretty warm again. One of the things we left with was the need to sort of stiffen the, here, I'll tell you what, while we're just talking, let me turn the current setting all the way in one direction, and we'll see if it continues to get hot. And if it does, then we'll know we're at max current, which I think it is already getting hotter. Let's turn this all the way the other way, and we'll see if that cools off in a jiffy. This is the point where I wish I had a thermal camera. I have one at work, but it's giant and chunky and from about like the mid-2000s. One of those cute, adorable little like attaches to your iPhone thermal cameras would be really helpful for being like, is this thing, which is currently at about maybe 130 degrees Fahrenheit, is it cool? Is it now at 128? Is it now at 132? And get sort of more instantaneous feedback. But that's just me. Oh, you know what I also could do, he said, is because the thing that matters is the current limit. We could look at the current draw on my power supply. Yeah, there we go. So now my power supply says I'm drawing 0 amps. Now it's 2.5 amps. How about we turn that down to like a cool 750 milliamps? That's how you can tell how much current your circuit is drawing, by looking at the power supply that's providing the current. Thomas says, have the exact same set of tiny and larger knockoff Dremels. Definitely the same tool. Yeah, I definitely... where did they go? Oh, here we go. Yeah, like this one, it shows up in all kinds of things for like, I think this was less than $10, and the other one was like $15. And it's fine, it does what I need it to do, which is like, I need to just like grind a little bit off of this thing. I need to engrave on this bit of soft metal or plastic, or I'm tired of hand filing this thing. I need to just take a little bit of a little bit away. And then this one's like, I need to grind. I grind a D shape into my steel shaft, and this one's it's certainly, so we have a couple of Dremels at work, and like they are a similar form factor. They're probably a little bit smaller and probably about half the weight. Like, I don't know what the difference in construction is, but this one is really beefy, and not super dexterous. But, it was also, I think, $15. So what are you going to do? What was I saying? Oh, so one of the things we had left with last time, which turned out not to be a huge deal, is we were seeing when we were putting force in from the stepper motor, we were seeing a fair amount of torque across this linkage, right? We were seeing this twisting, we were sort of binding on this front bearing here and not getting a lot of rotation out of it for that reason. And frankly, what helped the most, so I experimented with it, was like, I took another one of these and I glued some like brass rod across it just to try and I figured this would be a pretty weak point. Like, it's not a particularly strong mechanical design. It's kind of just a plate on the bottom with 4 legs, and then this sticks up across the front. But just attaching this to the truss makes an enormous difference, right? The truss kind of becomes that additional structural member there. So I still see a little bit of torque. You can probably see as I rotate this back and forth, you see a little bit of like jumping and wobbling in the mechanism there. But it's nowhere near as bad as it was, and the thing actually does run, which is, a huge perk and much better than we were doing before. You might also notice, if you look closely, and I can help you look more closely through the magic of cameras and the magic of hiding things. There we go. Well, now we're really in the guts. So this, of course, is our drive, our pressure wheel, we've been calling this, that is on a threaded attachment onto our drive barrel, and there's these 2 friction washers in between that would be interfacing with this ratchet. And you might notice that not only is the ratchet mechanism itself not in place, but these friction washers aren't actually engaging with anything. So the reason for that is me being having the smart thought was like, well, this drive barrel we know is under a lot of pressure. In fact, we snapped one last time and actually snapped one earlier today. Why don't I print these in PETG instead of PLA like the rest of this, and then it'll have hopefully some additional mechanical strength, which it does, and that's good. And its failure modes, in my opinion. The failure mode of PETG, I don't know on an absolute scale if it has more strength before breaking, but PLA is somewhat brittler in my experience, because PETG has a little bit more give before it breaks, and so for like an active mechanical part like this, it can be nice to have PETG as your medium, because then at least it's not going to sort of shear at the first stretch. You have a little bit of like bend and wiggle before things get really bad. At least that's been my experience. What it does mean, though, is we had sort of confirmed the fit of the pressure wheel and the drive barrel and that thread in between them when they were both PLA parts. And now having one in PETG and one in PLA is not going great. Like, this doesn't thread more than maybe 2.5 threads, even well oiled up and with a little bit of like filing of the threads. So I'm a little scared to do that. These just don't want to have like the nice smooth interface that we were seeing when they were both PLA. And without that smooth threading action, there's no way for us to have this ratcheting action, right? That depends on this pressure wheel being able to tighten and loosen on the threads of the barrel as the motor rotates one way or the other. So now that this design is feeling a little bit more stable, I might go back to printing this part in PLA, or maybe both parts go to PETG. I'm not sure. But for tonight, basically I said, okay, we're not going to worry about the ratchet tonight because I haven't redone the ratchet yet anyway. We'll sort of disengage that mechanism. This is threaded on tightly enough. The pressure wheel is threaded on tightly enough to the drive barrel that it's locked in place, essentially. There's one that we've taken the ratcheting part out of the equation, and we're just using this to sort of directly drive the barrel there, which is not the most exciting thing, I will entirely admit, but for the purposes of like doing some stress testing this evening, I thought that would be sufficient. Speaking of stress testing, I'm going to grab some of my... So, as I think I mentioned before, my wonderful wife, Mary, who says hello to all of you, helps me do a little test setup before I do these Sunday night streams. I set up on a dummy account and set up a stream from me to YouTube to our living room where she's on her laptop, and she goes, "Oh, that sounds good." Or, as is the case tonight, your microphone sounds really weird. So I had this just sitting here as I was doing that test, and she kept saying, "Ook, ook, oh, okay, ook, ook," and Man, I tell you, I'm not a particularly context-observant person. I did not know what was going on for the longest time. I thought she was trying to tell me maybe there was like a monkey outside of our window, or maybe there was... I didn't know what. No, she was just reading the thing on the screen. So she's, as usual, a smarter person than I. Let's see here. So now... I've been threading a little bit of this. This is just 28-gauge galvanized steel wire that I picked up at the hardware store. And we'll use that as our demo lifting line for tonight. Let's roll that onto our spool here. You can see I'm using that, since I have that big fat grub screw. Oh, that's not going to be good. I have that big grub screw in there anyway. I'm just using that as a tie-off point for our lifting line. Just wind that onto the line a little bit so we're not really in any danger of it spontaneously coming detached. I will say this is pretty satisfying. This project, of course, has been in the pipeline for so long, and having it like be able to, with a stepper motor, wind. Less satisfying when the button just flies off your breadboard, but the ability for the, it's starting to look like something. It's starting to look like a winch. It's starting to, it's got line wound onto it, and that's very exciting. So let me run. Let me run this out again here. Run out a little bit more line. Spooling. I know, right? Go figure. It's a little thing, but like after all this time looking at these spools and these and this batten and things not spooling, it's very satisfying. Let's zoom that out a little bit here. Let me get rid of my okay. So what I thought we might do tonight to do this stress test, and it's not going to be a particularly scientific one, but at least where I want to start is just kind of replicating the results from last time, which you'll recall, I think we used this pair of vice grips as our test weight. But this time, I think with the length that this truss is, I can kind of, maybe I'll zoom way out, so I stand a chance of seeing it. I can kind of wedge this truss into a part of my desk setup here that's going to prevent it from going anywhere. And then we can actually apply some force to this thing. Let me see here. Should have tested this a little bit before. This is not going to be quite as secure as I had hoped. Or rather, it's going to put some pressure on parts of the setup here that I do not want it to. I guess I could just screw it straight to the workbench. That would be a way to go. Or weight it down. Or honestly, I can just hold this in place, and if I weight this string down, and again, that'll be off camera, but I can still have one hand free to operate things. Let's see there. All right, so let's run this out a little bit more. I might have to come back and make this operating line a little bit longer. I think it'll be okay. Oops. Now, because I have this big derpy like handle hanging off this spool, it is particularly prone to getting caught, which is not ideal. Maybe I should have done this on the other spool, although then this would be so far from the business end of things, be a little hard to show y'all what's going on. Oh, gaff to the table, says Chris. That sounds like a decent idea. This like vinyl tabletop is not actually secured to the wood underneath it, which makes things a little bit complicated. What did we... Oh, you know what we did? We used the vice grips to like hang a heavier thing off of this. That's what I think it was my water bottle last time, wasn't it? I need a third hand. I need like a... So one thing I've been trying to convince myself is worth the order, and I haven't yet, and I don't know why, because, well, this is the moment I would need it, is finally in the past 12 months, you can get from AliExpress decent, relatively low force gauges. Digital force gauges that will maintain their maximum, which is something I would love to have for something like this so that I could, pull on this until it breaks and then be able to go back and say, okay, its maximum braking force was 6 newtons or whatever it was. So this is just with, I'm just lifting the pair of pliers up and down here just for interest's sake while I think about what the heaviest thing I have ready access to is. I meant to bring my water bottle in, I always do, but I think I have forgotten it. But that's going to be like 3 or 4 pounds, which might be the place we want to start. So here, if you'll excuse me but one moment, I will grab that as our test weight. BRB. Chris, you nerd. Yeah, you could figure out how much this actually weighs. Well, here, if someone was curious, this is a 32-ounce water bottle that is, let's say it's full. It's within 5% of being full, and the bottle itself is of negligible weight. How much weight is that going to put on our test line here? If it's too much, then I'm just going to have to hydrate until this thing works, which is pretty great. All right, so you get the vice grips back up here. Here, let me spool out a little bit more line, just so we have a little bit more to work with. This water bottle is not going to be hanging directly inside of my legs. And what we'll do is we'll just reach... I think this is what we did last time. We'll just reach down through the handle and use the vice grips to sort of grab the wire. And that'll sort of trap things in place, I think. All right, lowering, putting under tension. Oop, nope, vice grip slipped off. Well, if that ends up being the weak point of our system, it'll put kind of a damper in this particular plant. But I think this is what we did last time, although that was later in the evening, so I probably had been hydrating somewhat better to that point. And we'll just spin that through. I've tightened the Vike script some. Clip that on. Chris has about 2 pounds of water for 32 ounces. All right, let's put that back under tension there. Hanging down. All right, so you can't see it, but this is now under tension. Ooh, and we can probably see, I can see the bowing of this mechanism, right? Everything's kind of, and as Thomas predicted, we have stalled the motor. So we haven't broken any of the structure, which I'm actually quite delighted by, but the motor will not turn at the moment. Although, oh, I take it back. Well, let's see. Motor can go down. Will it go up? No. Well, it's trying. It's skipping steps. Can you see that? Here, maybe I can, with one hand, while I prevent this thing from running away, maybe I can put this in a slightly better spot. Maybe move that other camera out of the way. Here, you don't need to see me for this. So, as I spin down, the spool is happy to spin down, but as I spin up, the motor starts to skip steps pretty badly. Needs more current. So I'm running about 900 milliamps right now on what is, I think, nominally a 1 amp max NEMA stepper motor. So I guess I'm a little bit afraid to, especially because it was so hot earlier. Clonk. But speaking of things being hot, now would be a good time to hydrate with some of this delicious water. I should say my beer of the evening, I'm not going to grab because I have 70 things in my hands right now, is an empirical subatomic hazy session ale. It's fine. It's very watery. I picked it because it's very thirst quenchy. Thomas, it is hot. It is no longer just warm. It is, the stepper motor is hot. All right, so that's about a quarter dranken. Here, maybe I will turn the voltage up on this stepper motor, and that will help with our currents. I actually forget what the nominal voltage on these was. Here, maybe that's something I can look up real quick. Let's see. I'm gonna do this on the separate monitor because you don't need to see my secret order history with my with my secret NEMA stepper motors that no one knows about, but they're from Amazon.com, and I've linked them in the description. Maybe. I don't think I actually did. So these are nominally 1.5 amp stepper motors. Do they have a maximum voltage listed? Nominally 1.5 amp. They have 500 volts DC of insulation resistance. Stepper motor voltage ratings are kind of irrelevant. I'll say something like 3 volts. Oh, well, I'm currently running at 25 volts. Is that too high? Perhaps. My thought was like, well, if we need for the same amount of power, higher voltage, less current, less heat. Although, I don't know that anyone should be taking my advice on on heat-related matters, as it seems. But let's do like a little experiment. So I'm going to, again, hard to demonstrate. I can zoom you back a little bit though, but you can all imagine what clip. Maybe you can't. I'm clipping the water bottle. I'm clipping this 28 gauge steel wire to my water bottle using this pair of Viper scripts. You know, just like everyone does. You know, just another Sunday night here in Chicago. All right, let's put that back under load there, and now we really are slipping. Ooh, now the stepper motor won't even hold. Do you see that? It's spinning on its own. I guess you can't tell whether I'm pressing the buttons or not, but that was just like spinning. The motor was just slipping freely under load, which is not ideal. Now, here's a thought. Because these stepper motors are rated by current, if we say this is our new nominal supply voltage, we could up the current limiting on the driver here, I think. Back up to around 1 amp, which should give us more power, right? That's how that works in theory. Ooh, yeah, come back. Come back. Yeah, slipping again. Well, let me do another quick hydration break. It's a highly accurate scientific test. The other nice thing about this physical microphone is I don't feel the need to mute myself, so you don't hear me glugging, and then I can't forget to unmute myself, so you can't hear me talking.